Hello everyone and welcome to our design thinking presentation for first year seminar. And without any further ado, let's get right into it. So instead of trying to jump immediately into like a design phase or try to start prototyping immediately, we actually needed to start with the empathize phase. And that's because we found it more important to really focus on what group do we actually want our project to help ultimately instead of what are we trying to make right off the bat. Because if we really started with this step, it'll help us better create a product and think more in the shoes of the kind of people we're trying to help with the project we're making. So ultimately there's a lot of different identities and groups of people you can pick from, but we decided to pick Northeastern professors teaching in non-STEM fields, or at least those who have a lot less experience and exposure with technology, because with recent events, technological innovation in the classroom has become very common. There's been a lot of more online things happening in class, and so it's important for teachers to really keep up with this change and adapt to the technology. But a lot of these teachers that teach in particularly non-STEM fields don't necessarily have as much expertise in technology that they might need to have in order to effectively use this tech in the classroom. So what we did is we first interviewed a first year writing professor, and from that interview we really gathered a lot of useful insights into how we could design our project to better suit this group, particularly knowing that a lot of professors really struggle to fully use the technology they have, or in the case of older halls, the technology is just too outdated and they just need a lot more instruction and help to effectively use that technology. So with this information, we can move forward with our next step.
Okay, let's move to the part of define phase. Let me introduce our point of view statement first. Non-STEM Northeastern faculty that are teaching online or hybrid needs to learn how to use technology for teaching because non-STEM Northeastern faculty has difficulty fully utilizing technology in a class setting. We all know in point of view statement, there are three elements which are users needs and meaningful insights. So obviously the main need of users we want to focus on is to help them use technology for teaching. And our meaningful insight is we found that sometimes faculties will meet some difficulties when they want to use some technology in teaching. To sum up, our goal is to think of a strategy to help faculty learn how to use the technology in class. So the how might we question comes out. How might we design an education system concerning non-STEM Northeastern faculty's understanding or use of technology when teaching? Also, there are three very important requirements of how might we question. They're open-ended, concrete, and testable. There are many different ways this education system could be implemented and accessed by faculty, so the question doesn't limit possible changes. For concrete, we're trying to specifically address the faculty's need of a further understanding of technology in the classroom environment. Also, our question is testable for by polls and their polling figures from either the students' adjusted experience after having their professors learning how to better use technology or from the faculty's teaching experience after having learned that for their classes. Therefore, our how might we question successfully satisfy those three requirements?
In this phrase, firstly, we prefer to create an application or the website that can help solve such common technological mistakes. And also in application or the website, it will have a North System specific Q&A message board, and which is used to solve such common technological issues. So at the same time, there is a problem. If the issues are now listed on a Northeastern specific Q&A message board, where to ask? In order to solve such exclusive issues, we will provide a chat box to answer, like the virtual assistants or student volunteers. They serve in the chat boxes. and help professors to create a planning tool for the class step by step. Also provides the guides for the usage of Canvas, Zoom, or other relevant applications. After creation of an application or website, in order to announce our project, we prefer to use poster or flyers to show how the project is effective to use technology for faculty when teaching. And in our group, we did not have any disagreement about selecting ideas, and we choose the idea of creating an application that let professors directly have access to the call or test individually, with the tech specialists, just like the IT service or the student volunteers. Are connected through the application with the quick response time to effectively and hastily resolve the problems for technological issues. As a group, we talk through all the ideas listed and point out the ideas that stood out to us. Was grouped into the rational choice for us, and since most group members referenced this idea, therefore we saw it as a clear win. So, since almost all group members were in agreement that this is the best idea to come from the ideation process, and we wish to further pursue.
The next design thinking phase we went through was the prototype phase. Because we wanted to focus on the feedback we'd get, we created simple sketches at first for our app's layout. These low-fidelity prototypes could be created and iterated quickly, so we could easily make changes after receiving feedback. And after getting all of that feedback, we could create a final design. And so these are the prototypes we used. The 3 on the left were the first prototypes, and the 2 on the right were added after that. And from the left, the first image represents a screen a user would see when they open the app initially. And the buttons are labeled with icons in order to make their purposes clearer, and the simple design should let the user get where they want to be quickly. The second panel represents the screen users would see after deciding to get support over the phone. The date and time slot is there because we weren't sure what the flexibility of the IT department looks like. The third panel represents what the user would see when reporting an item as damaged, asking them to describe what's broken and enter the identifying serial number on the piece of equipment. That way it could be replaced. The last 2 panels were added as prototypes to incorporate some of the feedback we got. The first of those 2 is the message support layout, which just represents the item in the menu that we had previously. And the last panel is a frequently asked questions page, which was part of our feedback, and would help address some of the simpler problems that a teacher might encounter with their technology.
So to start with this slide, we're going to be going over the users tested and the feedback that was received. So our target user was a first-year writing professor, i.e. a non-STEM faculty at Northeastern. And then for our CS1200 TA, we did the testing phase with Andrea Joshua. And for our other user, we interviewed a Northeastern undergrad student. So in terms of positive feedback, a piece of positive feedback from the student tester was that the student thought that the app would be a great idea, as there was a time during class in which one of their professors spent half the class trying to fix a technological issue, and that process would certainly have been expedited using our app to help. Another piece of positive feedback from the CS1200 TA was that the design seemed very well done and quite easy for people of all technological backgrounds to use effectively. And lastly, a piece of positive feedback from the professor was that this seemed like a great tool to use whenever there were technological difficulties in the classroom. So now going on to the negative feedback, a piece of negative feedback from the student was that even with how simple the app is to use, it may still be too difficult for some professors to navigate that are older or not as tech savvy. And the CS1200 TA did not have any negative feedback or criticism for the prototype, saying that it looked like a great prototype. And lastly, a piece of negative feedback from the professor was that the overall aesthetic of the app, based on the prototype, could be a bit better, as it could be more colorful or have a better font. So moving on to the next part of our test phase, the constructive feedback incorporation and social identity differences. So in terms of constructive feedback, a surprising piece of feedback that we gleaned from our test was what would the average response time be for these inquiries, and would the response time differ if it was in-person help, phone call help, or text help over the app? And that, I believe that to be a important piece of constructive feedback to consider. Another surprising piece of feedback was that we could include an FAQ for common questions about technological issues on a specific page of the app for people to look at before directly communicating with someone from Northeastern Information Tech Services. And in terms of incorporating this feedback, we'll make sure to give the prototype a more unique look and feel, closer to the final project, to making it less dry and monochrome in style, while also trying to simplify its design and make it more digestible for non-tech savvy people, and also add in an FAQ page to increase the speed in which professors can have their issues resolved. And lastly, in terms of different social identities and interactions with the product, the only difference that we could glean would be how one were to interact with the product if they were a STEM versus a non-STEM professor, as a STEM professor would likely have a more in-depth understanding of technology and would therefore be able to understand a more in-depth explanation of technology when like someone is trying to help them with a technological issue compared to a non-STEM professor. And because of this, we wanted to try to keep it as simple as possible when explaining how to resolve things with technological issues, to include everyone and make it inclusive for everyone to understand. Lastly, in terms of the reflection, our takeaways and how they relate to computer science and what we're studying at Corey. So one major takeaway was like going through this entire design process of designing a product and all these different steps, which is something we're going to do a lot in computer science when we're designing maybe a big project like an app, or even something that we go through in a smaller scale with like a simple function when we're coding. And another takeaway that we gleaned was that we were able to go through preliminary designs of a smartphone app, even though we're not actually coding, and we were able to figure out what it does and what works and what doesn't work based off the feedback we had from our user test, which was very helpful. And it was really interesting to experience that whole process and go through it. And yeah, so that's it from me. Thank you very much.
So, after going through all of the phases of design thinking, we were ready to make our final product. And so for our final design, we made changes to incorporate all of the feedback we got. When making the app layout, we tried to remain consistent with other Northeastern mobile apps, using a light-themed menu with red accents on buttons and some text pieces. And the app frames were all made using clear fonts that are intended to stand out more, and the accented icons make it easy to know what each button does with a quick glance. Within each page, prompts are added to each of the text fields in order to show what the user should type there. And we added light red accents in order to emphasize different texts from others. And in the case of the damage equipment page, this was in order to indicate that the serial number is an important field item that must be identified. And in the message support page, it differentiates the user's messages from the support messages. In the frequently asked questions page, answers were given a lighter shade of gray so that the user could quickly scroll through the page and find out if a question might match theirs without having to read all of the answers. And this would save them significant amounts of time if there are a lot of frequently asked questions on that page. And so with this prototype of an app, we believe that teachers would be able to easily get help for any of their tech support issues that they might have during classes, and that this would make the process much easier.